Lesson, we are going to continue with differential calculus. Now we are going to look at the stationary points, and sometimes we may have two stationary points, or sometimes we may have one. So one stationary point may be maximum, local maximum. The other one may be a local minimum. Okay, so now let's first look at where we have a local maximum. So a local maximum can be obtained when a parabola opens downward. So here we have a curve where a parabola opens downward. Now the point here where the curve is turning, this point is what we call a stationary point. Now at stationary point, the gradient is equal to 0. So the gradient of a curve at stationary point is equal to 0, or we can say the first derivative of a given curve is equal to 0. Now, to the left side of the stationary point, we have the gradient where the gradient will be positive, or we can just say the first derivative of f of x must be greater than 0. While to the right side of our stationary point, here our gradient will be negative, so we are expecting a gradient that is less than 0, or we can say f prime of x is less than 0. So this is what we can demonstrate about the local maximum, or where the stationary point represents a local maximum. Now, as we can see, if we have a number line where, let's say we have 0, 1, 2, here we have -1, let's say we have -2. Now, as we can see to the left side of the stationary point, let's assume the gradient is equal to 2. So we can see if the gradient is equal to 2, then if we move, we are going to have where the gradient is equal to 0. Then if we continue moving, we are going to have this point to the right side of the stationary point, where we can assume that the gradient is equal to -2. So for a local maximum, we are able to see that we are coming from a greater number going toward a less number. So here we are saying that we are decreasing, there is a decrease. So therefore, the graph of f has a local maximum when first derivative, which is f prime of x, is less than 0 to the left of the stationary point, and where f prime of x to the right of the stationary point is less than 0. Okay, let's have a case where we have a parabola that opens downward. So we can see that here we are going to have a gradient that is equal to a negative number, or we can say f prime of x is less than 0. Then for the stationary point, this is where we are expecting to get a stationary point. Now for this one, since it is opening upward, this now will be a local maximum. I mean a local minimum, since we are expecting to have a y value less than for the local maximum. So now here we are expecting to have a gradient that has a positive value. So f prime of x must be greater than 0. So if we are to draw a number line here, we can see that, so we have 3, here we can say we have -2. So as we can see, we are moving from a negative, then going to the positive. So for a local minimum, the graph of f has a local minimum when f prime of x is less than 0 to the left of the stationary point, while f prime of x is greater than 0 to the right of the stationary point. So therefore, if you are asked to find the coordinates of the stationary point, you should equate the gradient is equal to 0. Okay, let's have another party. Okay, now let's say we have a curve moves like this, then it continues moving. So in this case here, we may have neither maximum nor minimum. So what I mean here, we can see that here our gradient will be positive. Then if f prime of x must be greater than 0. At this point here, at this point, we are expecting to get, we can say this point, we are expecting to get gradient is equal to 0. Then f prime of x also equals to 0. Then as we continue moving, so we can see that we continue moving upward. So here also the gradient will be positive. Then f prime of x will be greater than 0. So under this curve, there is only one stationary point and we cannot identify whether it's local minimum or local maximum. So here we can say we are moving from a positive number to 0. Again, we start moving toward a positive number. Now let's also have, maybe let's say we have a curve like this. So a curve that moves downward. So here our gradient must be equal to negative number. F prime of x must be less than 0. Now at this point we have the gradient where is equal to 0, or f prime of x is equal to 0. Then if we continue moving down here, we are going to have a gradient that has a negative sign. F prime of x will be less than 0. So in these two cases, if you have this graph, there will be no local maximum, no minimum. Also to this part here, we are also not going to have a local maximum or a local minimum. Now, after knowing this, let's have some examples. So let's look at the first example. So the first example is we are going to find the stationary point of f of x is equal to x raised to the power 3 minus 3x squared minus 9x minus 5. So if the question is find the stationary point, the first step to do is we need to find the first derivative of this equation. So we are going to differentiate. So let's say we can say now f prime of x is equal to, so we're gonna bring our 3 to the front. We have now 3x, 3 minus 1 minus, so we are going to bring our 2 to the front of x, so it becomes 2x, 2 minus 1. Here we are going to differentiate x raised to the power 1. So x raised to the power 1 is just equal to 1. Then the derivative of a constant number is 0. So let's continue. Let's simplify now. So here we can see that we have 3x squared. Here we are going to have 6x raised to the power 1 minus 9 times 1 is 9. So now after you are done differentiating, you need to equate now, because we said at the stationary point the gradient is equal to 0, or f prime of x is equal to 0. So where there is f prime of x, we are going to substitute with 0. So we get 3x squared minus 3x minus 9. So as we can see, we have formed a quadratic equation. So you can use the method that you feel like you're comfortable. You can use a quadratic formula, you can use factorization, you can use maybe the other method, completing the square, as long as if you are comfortable with that. Now in this video we are going to use now factorization. So factorization, we need to have a product, sum, and the factors. Now before we proceed with finding the product, the sum, and the factors, let's reduce. So since we can divide each party by 3, here by 3, also by 3, so that we can reduce. So 3 into 0 is 0. 3 into 3 here we cancel, we have x squared minus 3 into 6, 2x minus 3. So here we have A, B, C. So the product is found by multiplying A times C. So let's identify the value of A and the value of C. So the value of A is the number in front of x squared, which is 1, multiplied by the value of C, we have negative 3. So 1 times negative 3 is negative 3. Now the sum is just equal to the value of B. So the value of B, we can see that we have negative 2. Now factors. Factors are two numbers that we can multiply to give us negative 3 and added to give us positive 2. So in case if you have challenges in terms of finding the factors, we can use this method. Let's say we have 3 here. So we are going to find a number that can go into 3 without leaving a remainder. So 1 can go into 3. So 1 into 3 is 3. It's because I know that if I multiply 1 times 3, I'm going to have 3. Now, since our product is negative, one of the two factors must be negative. So here, this number, since the product, this number, our 3 must have a positive, then this one must have a negative. Why? So that if we have negative 3, negative 1 plus 3, we are able to get positive 2, which is our sum. So therefore, the factors are negative 1 and 3. So we can now continue. So say x squared minus x plus 3x minus 3 is equal to 0. So now after this, we can now factorize by grouping terms. So we factorize this part here. So what is common here is x minus, so x into x into x, we get negative 1 plus what is common here is 3. So 3 into 3x is just x minus 3 into 3, 1 is equal to 0. So we can now see that we have this as a common. So we can now factorize. We get x minus 1 is equal to 0. Before we equate to 0, first let's finish factorizing. Then this x will pair with this 3. So x plus 3 is equal to 0. Then we are going to equate each to 0. So x minus 1 is equal to 0. If we solve for x, we can see that the first value of x is 1. Then for this one, we can say x plus 3 is equal to 0. X is equal to negative 3. So we are done finding the value of x. Now, number 2, we need to find the values of y corresponding to these values of x. So let's first find the value of y by using 1. So when finding the value of y, you need to use now the original function before it was differentiated. So now let's proceed. So where there is x now, we substitute with 1. So 1 raised to the power 3, 1 raised to the power 2, and 1 raised to the power minus 5. So 1 raised to the power 3 is 1 times 1 times 1, 1. 1 times 1 is 1 times 3, 3, minus 9 times 1 is 9, minus 5. So you can now see here we have 1 minus 3 is negative 2, negative 2 minus 9, negative 11, minus 6, we get negative 16. So you can see that the first pair of coordinate is 1, negative 16. Let's also find the other y value where the x is equal to negative 3. So we can see now f of x is equal to x raised to the power 3 minus 3x squared minus 9x minus 5. So f of, now where there is x, we substitute with negative 3. Okay. So negative 3 raised to the power 3 is negative 27. Here also we have negative 27. Then Negative 3 squared is positive 9. 9 times negative, we still have another negative 27. Then negative 3 times negative 9, we get positive 27 minus 5. So we can just cancel these. We get negative 27 minus 5. We have negative 32. So the other pair is negative 3, comma, negative 32. Now, upon reaching at this point, let's compare the two values. So the first value is y is equal to negative 16. The other pair has a value of y is equal to negative 32. So among the two, the one with the greater y value is the local maximum. So here, this is a local maximum. It's a local maximum because its y value is less than, it means greater than the other one. So negative 16 is greater than negative 32. So this one is a local minimum. Then for the x value tells us the location where the stationary point is. So now let's have example 2. So example 2, let's say we have y is equal to x raised to the power 3 plus 9x squared plus 27. So feel free to pause the video and give it a shot. Now let's begin. So we can say dy over dx is equal to, so we are going to have 3x squared plus 9 times 2 is 18. 2 minus 1 is x raised to the 1 plus 27. The derivative of x raised to the 1 is 1. So dy over dx is equal to 3x squared plus 18x plus 27. Now at this point we can substitute the derivative with the value of 0. So here we can say 0 is equal to 3x squared plus 18x plus 27. So as we can see, we have a quadratic equation, and we can also reduce. We can divide by 3, also by 3, by 3, and here by 3. So here we have 0 to the power 2 plus 6x plus 9. So let's find the product, the sum, and the factors. Product, we say the value of a. So 1 times 9 is 9. Sum is 6. Now the factors, the two numbers that we can multiply to give us 9 and add to give us 6. So we said we can just use the product here. So we are going to do 1 into 9 is 9. So if we can check 1 times 9 is 9, we are able to get a product. 1 plus 9, we have 10. Or 1 minus 9, we have 9. So we are not getting the sum, which is 6. Okay, let's look at the second number that can go into 9. So 3. So 3 into 9 is 3. So let's try these two. So 3 times 3 is 9. 3 plus 3 is 6. So these are the two values that we are looking for because they are able to give us 6. So 3, 3. So we can now continue with our factorization. So 0 is equal to x squared plus 3x plus 3x plus 9. Then we can now factorize this part and also this part. So here the first part, the first thing common is x. Then x into x squared is x plus x into 3x is 3 plus here the common is 3. 3 into 3x is x plus 3 into 9 is 3 is equal to 0. So we can now get this common part. So we will get 3x plus 3. Then also this pair x plus 3 is equal to 0. So if we get each x plus 3 is equal to 0, x is equal to negative 3. So even this one will also give us the same value, where x will be is equal to negative 3. So under this problem, we are only going to have one y. And in situation where you only have one y or one pair of coordinates, now you have a condition where we say it's neither maximum nor minimum. So we can now find the value of y. So we said x is equal to negative 3. So we use our original expression. So let's substitute where there is x with negative 3. So negative 3 to the power 3 is negative 27. Then here 3 times 3, negative 3 times negative 3, positive 9, 9 times 9, 81. Here negative times positive, we have negative. Then 27 times 3, 27 times 3, we get 81. So we can see that this and this can be cancelled, so our value is equal to this one. So the pair of coordinates is negative 3, negative 27. So here we cannot tell whether it's a maximum or minimum, since we don't have another pair that we can compare with. Okay, let's have the last example. So we have y is equal to 2x to the cube minus 3x squared, 12x plus 4. So let's find y prime is equal to, here we are going to have 6x to the power 2 minus 6x minus 12. The derivative of 4 is 0. So here we said the first derivative is equal to 0. We equate here by 0. So 0 is equal to 6x squared minus 6x minus 12. We can reduce by dividing with 6. So here we have 0, x squared minus x minus 2. Then the product will be a is 1, c is negative 2, which is giving us negative 2. Our sum is b, which is negative 1. Then the factors. So since we have 2, if the product is 2, the factors are 1 and 2. So just 1 and 2. Okay, so here what are we going to do now? We need to assign 2 with the negative, so that if you add, you're able to get the negative 1. So we can now proceed. X squared plus x minus 2x minus 2 is equal to 0. So we can now factorize this part. X is common. X into x squared is x, plus x into x is 1. Here negative 2 is common. Negative 2 into negative 2x is positive x. Negative 2 into negative 2 is plus 1. So you can see that this pair is common. So we get x plus 1. We equate to 0. Or here we make this also, we can say x minus 2 is equal to 0. So x is equal to negative 1. If we shift 1 to the other side, here we are going to have x is equal to positive 2. So we can now find the value of y. So we'll begin by first using x is equal to negative 1. So y is equal to 2 negative 1 to the third minus 3 negative 1 squared minus 12 negative 1 plus 4. So we can see that negative 1 to the power 3 is negative 1 times 2, negative 2. Here negative 1 squared is positive 1 times negative 3, negative 3. Negative times negative, here we have positive 12 plus 4. So negative 2, negative 3, we get negative 5. 12 plus 4 is 16. So 16 minus 5, y is 11. So the first pair is negative 1, comma 11. Let's find the other pair. So this now will be x is equal to 2. So, okay. So 2x the third minus 3x squared minus 12x plus 4. So here we put 2 raised to the power 3 minus 3, 2 raised to the power 2 minus 12, 2 raised to the power 1. So 2 raised to the power 3 is 8 times 2, 16, minus 2 raised to the power 2 is 4 times 3, 12. 12 times 2 is 24 plus 4. Here we can see 16 minus 12 is 4. 24 minus 4 is 20. So y is equal to negative 16. So this value has, this pair has 2, negative 16. So if we compare, we can see that our 11 is greater than 16. So this one is a local maximum, while this one is a local minimum. So this is how you can find the local maximum or local minimum, or neither, using differential calculus. And that's it for this video. Thanks for watching.